All right, well, let's move to something else here. Have you guys done hydrates? Do you know what a hydrate is?
No.
So a hydrate is let's see, what would you call it? Like any ionic compound. And sometimes they like to suck water out of the atmosphere. And so when you're measuring this compound, you're actually measuring like not only the compound, but some of the water. Um, IB, they really love these problems. And so I would be shocked if you don't see a hydrate when you end up taking your paper ones and twos. Okay. So most of the time, what you're going to see on these papers is they're going to give you the salt and they're going to say something to the effect of figure out how much water was in the figure out how much water was in the sample. And so when you run this lab, what you do is this: you take this sample and you heat it, and you heat it until the mass quits changing. So you see right here, they said after the first heating, and it weighs this much, and then they do it a second time, and it weighs the same. If it didn't weigh the same, you would do it one more time. You'd heat it again. And so you would just keep heating it until the measurements were the same. And that's kind of the basics of how you do a hydrate. So let's just look what they gave us here. They gave us the mass of the crucible, the little container, the bowl, the mass of the crucible and the hydrate. So the salt plus the water. And then they gave you the heating. So you see how it gets kind of less, like it starts here, and then as they burn the water off, it goes there. So suggest why the sample was heated twice in the experiment. Well, that's just to make sure all the water's gone, right? To burn off all the moles of water. So the next piece is determine the mass of the hydrated sample used in the experiment, including absolute uncertainty. Have you guys done this?
Yeah.
You've done like the plus or minus like 0.0.
Yeah.
This be 0.01.
That's topic 11, right? Topic 11.1 or something.
That's right. Yeah, because in physics it's topic 1, but in chem it doesn't show up till 11. Hydrate. So this was the total. This was the crucible. And then so this is, I don't want to go too fast on this. So this is everything, SO4 times, whatever water. We don't know how much water. And this is actually it's plus the crucible. This one's just the crucible. So when I subtract these, I get just the Zn SO4. So that's going to be, I don't know what.
That's 13.2.
13.2 grams. So that's how many grams of that zinc SO4 that we had. Oh, I think I may have misread this question. I did not find. You guys got to speak up. I made an error. Do you see my error? Maggie, can you find my error?
No.
No, what do you mean? Okay, so when I subtracted these, I actually didn't find just the zinc by itself. What did I find?
Oh, and also the water.
Yeah. So I solved the question, but I interpreted it wrong. So I'm actually finding like this whole thing, whatever this is, and the mass of the salt. So we know how much what if I just do this? What if I just do this 37.43 minus the 30.03? Because remember, this is the crucible by itself. And what was this number? You guys look.
After heating.
Yeah, is after the heating. So what's in that crucible after the heating? Well, there's no more water. And so it's just the crucible plus the salt by itself. And so when I subtract these, what do I get?
7.4.
So there's my mass of the zinc sulfate by itself. Okay. Okay, you guys good on that? I know I kind of messed up here. Speak up if you didn't follow what I did. All right, so use your answers to part B and C to calculate the water of crystallization. Oh, wait, hold up, what? I think you're supposed to calculate the moles of water. So, is there a way to figure out how much water?
The after heating and before heating, the difference.
Okay, so like, let me switch colors here. So this one is kind of your before heating, and this one is like your after heating. And so if I subtract those two, I get the water by itself, right?
Mm.
Okay. And what's that going to be? 5.8. 5.8 grams of water, but that's not what I want. I want moles. So 5.8 over, what is it, 18? Oh, I need help on this one.
0.322.
Like that.
Mm.
So most IB questions are not going to stop here. This one does. What they're going to want to do is find the ratio between these two, ZnSO4 and the H2O. So what we need is, we need the moles of both. So we already have the moles of this one. Let's find the moles of ZnSO4. Yeah. Okay, what does that give us?
0.045.
Okay, so
Oh wait,
if
it's
I,
actually 4.6 because it's 5.8.
okay, so I want a ratio, and when they write hydrates, they write them like this, the ratio of the salt, and you just kind of want one down there, and to the H2O. So you're gonna get some kind of number up here when you do this. So all you do is this. You just take 0.322, which is your water, divided by your salt, 0.046, and hopefully you get something like a whole number. Please tell me you get a whole number.
7.
7. Okay. So the end of the question would be, what is the formula for the hydrate? So you would say ZnSO4 big dot 7H2O. Feel good?
Mm-hmm.
Yeah. Everybody feel good? Maggie, you feel good? Yeah. All right. So if you were doing this in this lab, um, what is one source of error that could happen in this experiment? What's going to throw you off? Well, what if you were heating it and you didn't get all the water out? Uh, that's definitely one source of error. What if you used two different balances, and because each balance isn't going to weigh, exactly like the other one. Um, those would probably be your two biggest ones that they would look for. Never put anything like some of it popped out or we lost some.